So in this video, I'm going to show you briefly how to find molar mass for compounds. So on the periodic table, there are values at the bottom that we know to be the atomic masses. And each of these values represents the grams per mole of a substance. So remember the distinction there. The grams represents the mass that is contained, right? Grams is a measurement of matter. But moles is a measurement of how many of the physical atoms there are. So these values represent grams per mole, which is essentially what molar mass is. Molar mass is a representation of how many grams there are in every 1 mole of a substance. So to find molar mass, you have to use these atomic masses that we just pointed out here. So a molar mass, if we want to find that, we want to find out the number of grams per every 1 mole of substance that we have, and we have values on our periodic table which show us per individual element the grams per every 1 mole. So it's actually quite simple. If you take a substance, for example, like NaCl, in every 1 NaCl molecule, you would have 1 Na, 1 sodium atom, or ion rather, and 1 Cl ion. Each of those would have a representative mass, the sodium 22.98, the chlorine 35.45. So to figure that out, to figure out what the molar mass of NaCl would be, you would just add up the mass of that 1 Na, the molar mass, the atomic mass of that 1 Na, plus the atomic mass of that singular Cl. And when you do that, 22.98 plus 35.45, you will get the molar mass of NaCl as an entire compound. So you're adding up your atomic masses for every ion that is present in your compound. So some quick math here. 8 plus 5 is 13. You got the 1 over here. So we got a 14, carry another 1. We got a decimal point, 8, 5. So 58.43. That number means that every NaCl, that every time we have NaCl, there are 58.43 grams in every 1 mole, or per every 1 mole of NaCl that we have. So if I have 1 mole of NaCl, right, we can even write that label in. Running out of space here a little bit. Squeeze it. So for every 1 mole of NaCl that I have, that would be a mass of 58.43 grams. If I have 58.43 grams, I have 1 mole of NaCl there. It serves as an equivalence. This idea is basically the same thing for every substance that we have. I'm just going to erase a little bit here. Actually, let's do it in the upper right. The only thing you really need to be careful about is making sure that you're always representing all of the substance or all of the ions that are present. So let's switch color. Let's go to blue color. So we did NaCl. We were adding up the mass of 1 Na and 1 Cl because there was 1 Na and 1 Cl in every NaCl molecule. One thing we just need to be careful of is if we have something that contains more than 1 ion. For example, calcium chloride. Calcium chloride, we have 1 Ca and 2 Cls. So if we're going to find the molar mass of calcium chloride, we need to account for all of the ions that are there. Both of the Cls and the singular Ca. We need to add up the mass of all of those ions. Again, we're looking at atomic masses here from the periodic table. So for CaCl2, we'll take the mass of 1 Ca, which is 40.08, the mass of 1 Cl, which is 35.45, and the mass of a second Cl, which is also 35.45. Right, so we've got our 1Ca, 40.08. We've got our 2 Cls, 35.45 a piece. Just add that up, and I'll do this on a calculator off to the side. Great idea for you to go ahead and do it along with me. Just pulling it up here. So 40.08 plus 35.45 plus another 35.45. The molar mass of CaCl2 as a substance is 110.98 grams, and again, that is per every 1 mole of the substance. And again, don't forget what that equivalence means. It means that every time I have 1 mole of CaCl2, I'm going to have 110.98 grams of matter. And it also means if I have 110.98 grams of matter, that's going to be 1 mole worth of calcium chloride. This is the same process that you would use for pretty much any chemical substance. The big thing again is just be very cautious of the number of atoms that we have when we're doing this.